Hi everyone, I am Balaji Chippada and welcome back to my YouTube channel. In continuation of our series Probability and Statistics, in this video, we will learn about a very important and interesting topic called population versus sample. And without any delay, let's get started. So let's talk about population versus sample and assume I have a task in which I have to estimate the average human height in the entire world. So there are multiple ways to solve this problem. So let's understand the first problem, which is my brute force technique, which is brute force. So what is this brute force technique? In the entire world, I have 8 billion population, right? So what I will do, I will collect the height of all of these people and then I will do an average. So what is average? Average is basically mean. So if I have 8 billion people, I will compute all of those heights and then I will sum it up actually. So I equal to 1 to 8 billion. So what is this? Average of 8 billion people height. So this will give me the solution to this question, right? So this is one way of tackling this issue. But is it feasible? Is it possible? So it is not, right, because you are a single person or maybe group of people and calculating height for 8 billion people and saving it and then measuring the average and then getting the result out of it is not a simple task and it is not feasible at all. So what we are talking, we have the whole 8 billion people and this is called as population. So what is population? So population is basically the whole of everything. It could be all the people on the planet, it could be all the values from all the sensors in a factory, it could be anything which is of massive size. So out of all of this population, I cannot measure the average because it is almost impossible to do. So that is where sampling is a technique that comes into picture and help you do this task. So let's understand what is sample and how you can get the answer to this impossible question. So this is interesting, right? So what I would do, I would take a group of people. Let's say this is some subset of people and this is call it as sample 1. And let's assume I am taking 10,000 people. So in this particular region, I am taking 10,000 people and I will be collecting heights of people. So out of these 10,000 people, I will collect heights from everyone and then I will get the average. So how I will get? I equal to 1 to 10k hi. So this is called a sample average. What we have done, we have taken some random 10,000 people from my population and we are calling it as sample 1, and we have taken a value of 10,000 people and we measured the height of all of those people and then calculated the average, which we call it as a sample average. So in terms of this statistics and probability, this sample average is equal to my population average. Okay, this is not a random variable, I'm just taking some example. So sample average is approximately equal to my population average. Now you might argue, how come it will be approximately equal to my population average? Because I have taken only some random 10,000 people, but there are total 8 billion people, right? Yes, you are right, and that is one of the backdrops, and how you can solve it I will also explain that. So the theory is, if you take some random sample, it is a random sample, and if you calculate the average of that particular random sample, you can estimate it to the population. So now, to most accurately answer this question, what I would do, I would take another sample. I will take another sample. I will take another sample. So let's say I have multiple samples. So I would say sample 1, sample 2. Likewise, I have sample n. It could be any number. And in each of these samples, I will be taking 10k people. So I will have the average sample 1 average sample 2, average sample n, and I will get the average of all of these samples. Now this average will be approximately equal to population average. You will agree, right? Because over the world, I have taken random bunch of 10,000 people multiple times and collected the average and then did the average of that one, and this will be approximately my population average. So this is how you can solve your question. Now you might ask, why only 10k? It is up to you how much number you have to take. It depends on what kind of use case you are dealing with, because we are dealing with a lot of people, like 8 billion. 10k doesn't seem much, but it depends on varies on use case to use case. So this is one thing. So how to solve this? If it is a very big population, take multiple smaller chunks of samples and do whatever you want to do and then estimate it to the population. So this is one of the way that you can use a technique called samples to get this thing done. And there are multiple types of samplings actually. One is random sampling, in which you will randomly take people from the world, and other one is stratified sampling, and the other thing is clustered sampling. So we have understood what is a random sampling, right? Now let's understand what is a stratified sampling. So we have multiple countries inside our world, right? We have America, India, Europe, a lot of countries in the world. So instead of taking people randomly from all of these countries, so let's take 10k samples from America, USA, and 10k samples from India, 10k samples from Europe. So likewise, every country we will get 10k samples and we will measure the average and then get the average of all of those samples. So this is also one way in which we are not missing out on any country average, because when you are taking average or randomly from the whole world, you might miss some countries, right? So likewise, you can get country wise samples and then get the average and estimate it to the population. You can do that. So this is called a stratified sampling. And one more thing is called clustered sampling. So let's say in India there are multiple states. People from, I mean, I don't want to be here anything regarding racism and all that stuff. Some people are of black, some people are of white, some people are of more height, some people are of short height, some people are of fat, some people are lean. So it depends on type of persons as well, right? So what we will do, we will cluster the people into multiple groups, and then we calculate the average of these multiple groups, and then we will estimate it to the population. So this is called as a clustered sampling. So what is a cluster? We are grouping people based upon some attributes. It could be anything. It could be based upon what kind of work they do. It could be based upon what age group they belong to. It could be based on anything actually. So clustering is one of the way that you can get the samples from and you can estimate it to the population. So these are all the different type of techniques in sampling that you can use to calculate or estimate to the population average. So I hope you understand the difference between what is a population and what is an sample. And in terms of machine learning, we use this in a lot. So let's say I have a data set in which I have 8 billion points, and then I want to train a machine learning model. Training a machine learning model on 8 billion points take massive amounts of CPU and then massive amount of time, and there are so many factors that it is almost physically impossible to train it on 8 billion points, right? In this scenario, what we will do is we will take a sample of data such that this sample covers most of the attributes of my population. Okay, and on top of this sample I will train my machine learning model, and I will generalize this machine learning model that is trained on a sample to my whole population. So in this way you will be reducing your time complexity, you will be utilizing less amount of CPU, and you are getting things done much faster. So this is one of the technique that we will use inside machine learning to train the models. And one more thing, let's say you are doing data analysis, and I have, let's assume you are doing COVID analysis. Okay, we have 8 billion people in the world. This is the whole population, and you want to calculate some stats such that how much percentage of people got vaccinated. The first brute force way is to get all the list of people who got vaccinated from the population and then get the percentage of value. That is one thing. Or else you can take, let's say, India. So this is, let's assume India. You have multiple states. So what you will do is you will get the information of bunch of people from each state, and then you will estimate the percentage of people who got vaccinated in that stage. You will not take all the people in that particular state, but you will take a sample which covers most of the region of the particular state, and then you calculate the percentage of people who got vaccinated, and you repeat this task for multiple states, and then you generalize it. Okay, 75% of people across India got vaccinated. This is not an accurate number, but it is almost similar to my population. It could be true, right? So this is one of the technique that we will use in terms of data analysis as well. Now what we will do is we will quickly jump into the coding part and understand what is happening. So here I have creating a 10,000 data points, and it is basically people's height. Okay, and then let me show you this. Let me cut this and here, and let me print this. So if I do this, I have, see, multiple people heights. Each of them you can consider to be a height, and this is a population of 10,000. Clear? Now what I am doing, I am getting a random 500 people from this population of 10,000, and then I am calculating the mean and standard deviation. So this, if I execute this here, and if I say sample heights, so this sample heights is basically the first sample in which I have randomly taken 500 people's height. And then what I'm doing, using a Numpy package, I'm calculating the mean, standard deviation of the population and the sample as well, and see whether there is any difference or not. If you look at this, my population mean is 169.98 and my sample mean is 170.00. See, there is not much of a difference, right? Even if I calculate the mean of 500 people, it is almost the same as the population mean. Of course, this number will get varied if you have a large amount of population, but I want to demonstrate. If you look at the standard deviation, it is also same. We will learn about mean, standard deviation in the later videos in detail, so don't worry. And I am taking this from a random normal distribution plot. We will learn about this in the next videos as well. So I want to conclude with one more thing. So let's say I have a population and I have a sample, and let's call it as population mean, and let's call it as a sample mean. So this population mean is equal to sample mean if my sample size is very close to population. That is also right? So I have a population, and if I take a sample which covers almost 90% of my population, this sample size is almost equal to my population size, then the mean of sample is equal to the mean of population. And it is not recommended to do these things, because why are we doing a sampling? Because you are not able to calculate everything on a population. So take smaller chunks likewise, and then estimate it to the population. So that is one of the important and very interesting techniques that you will learn, and you can apply this in any real-time object as well. So that's all for this video, guys. I hope you learned something new from this video, and if you learned something new, please hit that subscribe button and click that bell icon to get notified daily. We will keep on learning a lot of new things in this series, so stay tuned for more videos. Bye bye.